Alright, you guys just went through all the vocabulary of circles, and now we are going to see what the tangent has to do and how it can help us with circles. So now that we know what a tangent is, let's go over two of the tangent rules. So you should have a worksheet in front of you right now, and the first tangent rule is right here. And so it says, if a line is tangent to a circle, then it is perpendicular to the radius at the point of tangency. So hopefully we know how we break this down. So let's start with if a line is tangent. So the yellow line that we have right here that I'm turning green is our tangent. And this is called the point of tangency, the point that's right on the circle. So it's saying that if we have a radius that's drawn from this spot, so let's draw a radius in. Remember, radius starts at the center and goes to the edge of the circle. So the pink is our radius. So if we have a tangent line and a radius and they intersect at your point of tangency, we end up having perpendicular lines. And hopefully you remember what perpendicular lines mean. Perpendicular means that we're equal to 90 degrees. So right here we form a 90-degree angle. And where that's going to help us is we can do things we know with right triangles. So most likely we're going to end up doing the Pythagorean theorem. Woo woo. All right. So now that we understand that a little bit better, let's go on to the second rule. The second rule is even easier. So the second rule, if you look down at the bottom, states that if two segments from the same exterior point are tangent to a circle, then they are congruent. Whew, that is a lot of junk. So let's start with two segments from the same exterior point. So our exterior point is out here, and let's go ahead and call that A as being our exterior point. So if we have an exterior point and we have two tangents, so your two tangents are the two yellow lines right here, and they make a point of tangency where they are the two yellow dots. So what that means is that each of these segments from the point of tangency to exterior A is congruent to each other. So if we call those B and C, we know that BA is going to be congruent to AC. And I marked those with the two segments. So anytime you kind of see a clown hat or you see an ice cream cone, we could think of it as an ice cream cone, you're always going to use congruent segments. Okay, so let's go to the back side and let's look at some examples. So example 1 at the top is our example number 2 of tangent rules. So what you'll see here is that you have your two tangents and they meet at a common point. So what did we just learn about that? Hopefully you remember that you learned that these are congruent. So x is just equal to 28. It is that simple. And if you look at number 2, it's again the same picture. Even though they have arrows at the end and they extend, it's still the same picture. So any guesses on how we would set up 5x plus 2 and 7? You're right, they would be congruent to each other. So all you have to do is do 5x plus 2 equals 7. Solve for x, so we'll subtract 2. And then divide by 5, and we will get x is being equal to 1. Okay, so that's all you have to do whenever you see these like ice cream cone looking shapes. You just set them equal to each other and solve. Alright, now examples 3 and 4 on the back side are going to go with the other tangent rule where you have a tangent and a radius. So just to see what you got here, here's your point of tangency with that black dot. 8 represents your tangent line, and then the x is going to represent our radius. And so right here is where we have our right angle, is where the radius and the point of tangency happen. So what they want to know is how can we figure out the radius, that's x, if we know that the tangent line is 8 and we have this other segment that's 10. Hopefully you recognized already that we're going to do the Pythagorean theorem. So what I like to identify first is my hypotenuse. So 10 is my hypotenuse. And then x and 8 are going to be a and b. So I'll go x squared plus 8 squared equals 10 squared. This is going to be 64, so I'll subtract 64 from 100, and I'll get x squared equals 36. And so x is going to be 6. So my radius up here is going to equal 6. Alright, now another crazy looking one, although it's asking for the same thing, is number 4. So I'm going to highlight in black here these outside lines. These are your tangent lines, and the black dots here are your point of tangencies. And so what else we have is our radius. So 3 is our radius here. which also means that this has to be our radius over here. So I'm going to go ahead, since these are the same, as I'm going to write a 3 in there because all the radii are equal to each other. Then what we have is we have wonderful right angles. So what we really have are two congruent right triangles that are on top of each other. So we can use the Pythagorean theorem again as 3 squared plus 4 squared equals x squared, because x is going to be my hypotenuse, and that's what they want to find this time. So 9 plus 16 is going to give me 25, and so I take the square root of 25, and I have 5. And it's that easy. So that's all you need to do is know that if, back here, examples 1 and 2, you have the ice cream cone or hat type shapes, you're going to set them equal. And if you have these right triangle looking things with a radius and a tangent, you're going to set up the Pythagorean theorem.